Hello guys, thank you so much for visiting my channel. Again, this is Edward and I will be your partner in learning science topics. Alright, so if you haven't subscribed to my channel yet, please like and click the notification bell so that you will get updated on my latest uploads. Thank you so much and have a great day. Bye bye. Alrighty, so as promised, let us have a very short review in one of your topics in Science Grade 6. So in your Science Grade 6 lesson, it was discussed or you experienced that when you mix solid and liquid or both liquid or gases, you found out that it forms together a mixture. For example, if you mixed solid and liquid along the process, you observe that it forms a two physical characteristic. For example, water and ice. Now, when you mix these two things together, it forms a mixture that has two appearances, and we call it heterogeneous mixture. Gets? Great. Now you have also seen that if these two components are mixed together in uniform, like in having one appearance, it forms a mixture that has one face, and we call it homogeneous mixture. Okay, so again, let's have a short understanding or a recap that if the two substances are mixed together and it happens to have two appearances or two identified appearances or more, two or more, we call it heterogeneous mixture. Now if this mixture has one appearance, like for example water and a soy sauce, if you mix together it's black, so that's homogeneous mixture. Okay, gets? It's great. Now let's proceed. Now clear with regards to the homogeneous mixture and then the heterogeneous mixture. The reason why I select the topic about mixtures because our discussions for today will focus about solutions. Now this solution has a one single appearance mixture combination, or this is what we call the homogeneous mixture. So we found out that when sugar is mixed with water and it's dissolved, we're forming a solution. Now, in other words, sugar can be dissolved in water, or sugar is soluble in water. Now, not only solid or sugar can be dissolved in water, sometimes we can dissolve gas to water or liquid, or gas can be dissolved with gas. So that's forming a solutions. One example of gas plus gas solution is the air we breathe. This is the naturally occurring solution. So for your own consumption, I would like you to search or to find out using the internet or whatever reference what are the gases combinations on the air that we breathe. Okay, now for example of gas in liquid solution, you can actually refer how soft drinks is being manufactured, because carbon dioxide is mixed with liquid to get a better taste on the soft drinks, but that is a certain temperature. And also solid and solid, so we have actually, if the two metals are mixed together under certain pressure or temperature, we're, we're forming up a metal alloy, and that is a solution. So there are actually a lot of manufactured solutions available at home or in stores. What I wanted you to do is to get a sheet of paper, then list down on the other side, list down the name or the solutions type or the type of solution. Then on the second part, write down its physical properties, the color or uh, whatsoever physical properties that you can observe. All right, congratulations, and thank you so much for accomplishing your first activity by listing down the solutions that is available in-house or in stores. Now let's discuss some of these manufactured solutions. So we have vinegar, the soy sauce, what else, the butter, so you can actually see that it has one single appearance. Okay, now not only solutions can be found in stores or in house that is being manufactured, because there's a lot of a naturally occurring solutions. Number one of that is the ocean or the sea water. So the ocean or sea water is a combination of water and a lot of salt and minerals. So this salt and other minerals are coming from the nature. So when the rain pours down the valley and the mountains, so it actually washing out the minerals in the soil, then it is being flown, or it's being flowed out through streams and rivers and some other bodies of water, then it is being mixed together into the ocean collectively. Okay, some other naturally occurring solutions is the air we breathe. So again, I challenge you to research what are the components of the air that we breathe. Okay, and another is the hydrocarbons. The hydrocarbons is naturally occurring. It is being mined underground. So this hydrocarbons is being uh, processed through a fractional distillation procedure, so that it could be useful for human existence. So hydrocarbons, it produce oil, yeah, aside from oil like crude oil or gasoline, there's a lot of byproducts that is being used for cosmetics, for medicinal purposes. So it is still a solutions. Okay, now, let us go ahead and see what are the properties or characteristic of this solution. So, what I wanted you uh, to get or to gather are materials like salt, sugar, oil, and then try to get beans or any beans that is available at home. So what you have to do is mix these substances or materials with water, and let us see if the substance can be dissolved or not. Okay, so let us examine first sugar and water. Is sugar can be dissolved in water? Yes, of course. How many faces or appearance are being produced once one after you mix it together, like one. So which means sugar can be mixed with water and it forms solutions. But can we separate it through simple filtration process? Yes, of course. Using the filter paper and the funnel, and then there are some solid sugar molecules can be separated. One other procedure to separate that is by boiling or through evaporation process. So once the water molecules will evaporate, then the remaining residue that would be the sugar component. The same with that of the salt. Okay, now let us try to mix oil with water. Is the oil can be dissolved in water? If we do the fast stirring, yes, it can be dissolved, but once you stop stirring it out, then the oil will still separate. The reason being for that, because there is a non-soluble part of the oil, the non-polar part or the non-polar portion of the oil. So because the oil has a larger molecules with that of the water, then it can be separated through a simple filtration process. Okay, or better yet, lessen the temperature of the water through say, using a refrigerator or an ice. So we all know that once the oil is exposed with with a very low temperature of water, it will freeze. So that way you can separate that. How about beans, mung beans, or whatever beans? Is it soluble with water? Of course not, because of its cellulose component, and it requires a lot of process to mix it together. But under certain temperature, under normal temperature, it cannot be mixed together. Okay, but can we separate? Yes, we can simply scrap or scrape it out, or we can just simply filter it or use a net. Then we can separate those beans from water. All right. So exciting, right? So we will be discovering more and more properties of the solutions as we go through. So those are the basic thing that we can observe if a certain substance is soluble or not. Now, in water, for example, in water and sugar, so it forms a solution. There are two parts, or there are two components involved in a solution. So we have the solute, which is available, which is this solid, and then the solvent, which is the liquid. So solute is actually available in a lesser amount, while the solvent is on the larger content. So that is so the one of the basis, if the solute, if one of the bases, if we're forming a solution, if the solute is soluble or can be dissolved. For example, sugar. If sugar cannot be dissolved in water, then it is not water soluble. However, since on the actual settings, when you mix it together, it forms a solution because sugar is water soluble. So that's why we are forming a sugar solutions. Okay. So again, there are two components in a solution. We have the solute and the solvent, and the solute is the one being dissolved under certain temperature, and the solvent the one that dissolve the solute. And that properties of the solute, we call it solubility. Okay, so the solubility increases as the temperature also increases. For example, uh, in the case of oil and sugar, so I'm sorry, for example, on the case of oil and water, so under normal temperature, oil cannot be mixed with water. But if we will increase the temperature, then there are chances, or there are situations that these water molecules will mix together with oil. Okay, the solubility of the oil increases as we increase the temperature. Right now, on the case of for example, sugar and water, the sugar is soluble under normal temperature. But if we will increase the number, or the amount of solute, for example, if we will increase the amount of solute, so we are now going through the saturation part. So if we will saturate, how are we going to saturate? If we will increase the amount, or the amount of solute into the solvent, without adding up, of course, the amount of the solvent. So we are creating a concentrated solutions. Okay, so again, if we will add more and more solute into the solvent, we are producing a saturated solution. Okay, so saturated solution if we are increasing the amount of solute. Once there are the possibility of increasing the amount of solute into the solvent is we are increasing the concentration or the saturation. Okay, so when are we going to conclude, or when are we going to find out if the solution is concentrated? Very good question. Now, once the solvent can no longer dissolve the solute, that is the time where the concentration or saturation is achieved under normal temperature. So what we have to do is that we need to increase the temperature of course, to increase the solubility of the solute. In that manner, we are creating a concentrated solution. Okay. Now, what is the opposite? What is the opposite thing if we're going to increase the amount of the solvent or decreasing the amount of the solute? So, increasing the amount of the solvent or decreasing the amount of the solute, we call it uh, dilution, or we are diluting the solution. So once we dilute, in diluting the solution, we just simply have to reduce the amount of the solute or by increasing the amount of the solvent. Okay, are you following? Great. Alrighty, so before we will move further, let us have a very short recap on what we have discussed earlier about homogeneous. Homogeneous mixture is what again? This is a solution that has one single appearance. Okay, the properties of the solute affects the solution. So we can only conclude, we can only say that the certain mixture is a solution if there is a one single appearance only after we mix the two substances. All right. Then we have also discussed the naturally occurring solutions and then the manufactured solutions. We have also discussed and or learned about increasing the concentration of the solution by adding up more and more solute component. And we have also learned that by diluting the substances, this is actually decreasing the amount of the solute or increasing the amount of solvent. In other words, a dilute solution has a small amount of dissolved solute in comparison to the amount of the solvent, while the concentration actually refers to if the solute is has increased the amount on a certain solution. Okay, now we can actually determine or we can actually calculate the qualitative and the quantitative uh, expressions of the solution. So one of the method is by calculating its percent by volume. So percent by volume, which is the amount of the solute on a given volume of solution expressed as gram per 100 ml of solution. And the other way around is percent by mass, to which the amount of solute in a given mass of a solvent expressed per 100 grams of solution. So for example, one of the most popular example is the commercially prepared disinfectant, which is isopropyl or ethyl alcohol. So if the solution is labeled as 70% isopropyl or ethyl alcohol, which means that 70 ml of alcohol or isopropyl or ethyl alcohol is in the 100 ml of solution, which means that out of 100 ml solution, 70% is the alcohol content and 30% is the water. Okay. Another example for percentage by mass or percent by mass is, for example, 5% acidic solutions, which when we say 5% acidic solution is that 5 grams of acetic acid is dissolved in 100 grams of solvent. All right. So again, let us have a qualitative and quantitative expressions on the solution, on its properties. For example, uh, expressed by percent by volume. When we say volume, again, it refers to the amount of liquid. Okay, if the certain substances is labeled as 70%, which means that 70% of solute or alcohol is in the 100%, it is available on a certain amount of liquid. For example, in alcohol, again, as what I have mentioned a while ago, if 100, if 75, if 70% is the alcohol content, which means that 70% is on the 100 out of 100% solution. So in 100 ml of alcohol, 70 ml or 70% of that is alcohol, 30% is water or 30 ml. Now on the on the percentage side, the percent by mass, for example, 5% acetic acid, which means 5 grams of acetic acid is being mixed on a 100 grams of solvent or solution. Okay, so before we'll end this lesson, I wanted you to have a short activity. So let us have a short activity. So what you have to do is to find out if how many ml of ethyl alcohol is available in 50 ml in a 50 ml bottle, given that the alcohol is 70% solution. Again, what I want you to calculate using the idea that I mentioned a while ago is to calculate if how many ml of ethyl alcohol is available in 50 ml bottle of alcohol, given that the alcohol has 70% solution. What you have to do, comment your answer below, and let's see if it's correct, and show us your solution. You can actually use internet, guys. It's a lot better to research by your own, because discovery learning has a greater or more possibility of retention. So that's why I don't give everything in. I'm just giving you the concept. Okay, so again, I will be seeing you in the next topic. This is Edward, and thank you so much for watching this video.